This was one of the problems that you've had on previous tests. I don't think I changed anything, but I'm going to go ahead and go over this again with you. Now, this was a 20-point question, and it helps me to really see where you can and can't do things and where you're having your difficulties. Alright, so first of all, remember you're going to write your complete word equation. So, calcium nitrate plus sodium carbonate is going to give you calcium carbonate plus sodium nitrate. Alright, so here I can see whether or not you're able to, do a double displacement equation. That was, I think, 1 point. Now this one, the next step we've got to translate. This is where I can tell whether or not you know how to put your, go from your names to your formulas. Okay, calcium nitrate. That's a calcium with a +2 charge. Remember, nitrate has a -1 charge. So we've got to have 2 of them. So calcium nitrate sodium carbonate. Sodium has a +1 charge. Carbonate, -2 charge. So it's going to take 2 of these. 2 times 1 is 2 to give me an overall positive that'll cancel out that -2. So I'm going to write that Na2CO3. Alright, calcium carbonate. Calcium has a +2 charge. Carbonate, -2 charge. Sodium nitrate. Sodium +1. Nitrate, -1. Now, the next thing I wanted to see is that you understand the phases that these things are going to be in, and you remember a little bit about your solubility rules. Okay, so from going from here to here, I think it was 1 or 2 points per formula that you translated correctly. Okay, so now we're up to, I think, either 4 or 9 points in our problem. I can't remember. So remember that calcium carbonate, y'all did a lab with this. It's chalk. This is going to be our solid, our precipitate. Everything else is going to be in aqueous form. So you got, I think it was a couple points if you remembered to include these little phase indicators here. That's a real important part whenever we move on. Alright, now I haven't balanced it yet. Let's see, 1 calcium, 1 calcium, 2 nitrates, 2 nitrates, 2 sodiums, 2 sodiums, 1 carbonate, 1 carbonate. Alright, so this was a point for balancing. So I think we're in the neighborhood of 10 points now or something for this. I can't exactly remember. But I'm going to cut this and start on a different page. Alright, now the next part of our problem, we've got 72 grams of each of these things added together. This is turning into a stoichiometry problem. We want to identify the limiting reactant, determine how much of each thing should be formed, and then we're going to do a percent yield problem. So, let's see, 72 grams of both things. Okay, I start out with 72 grams of this, and I start out with 72 grams of this. Alright, remember that we're first of all going to need to know what our molar mass is of each one of these participants in the reaction. Now, this I think was worth 1 point per calculation. I'm going to do one problem for you and then just write down the rest of the numbers. And I'm also going to round. I'm not going to be exact here. Alright. Let's just take this calcium nitrate for example. Calcium, we've got one of them. And we're going to say 40 grams per mole. Now what I'm doing here is I'm going to show you one calculation where I'm determining the GMW, the formula weight, the gram molecular weight, formula weight, however you want to call it. I'm going to do one calculation and then I'm just going to write the rest of the numbers down for the other ones. Okay, we got one calcium, which is 40 grams per mole. I got that from the periodic table. I've got two nitrogens here, and those are 14 grams per mole. I've got 6 oxygens here, 16 grams per mole. Alright, so 1 times 40 gives me 40. 2 times 14 is going to give me 28. 6 times 6 would be 36. That'd be a 96, I believe. Add all these together. 14, and I believe we get 164. Let's see. 8 and 6 is 14. That's 5 and 2 is 7, and 9 is 16. 164 grams per mole. Okay, so this is how I determine my gram formula weight. So you're going to need to do that for each one of these. Now I've shown you one example, so I'm just going to give you the numbers. Okay, so right underneath here, I know that this is 164 grams per mole. I'm going to copy, or I'm going to get rid of this just so I have some more room. Remember, I'm doing rounding here because we're just not going to be worried about the significant figures with this problem. Sodium carbonate, 106 grams per mole. Calcium carbonate, 100 grams per mole. And then sodium nitrate, 85 grams per mole. We've got to look at our mole ratios here because the mass isn't really what this is all about. We've got to look at our molar ratios. And what this is saying is that according to this chemical equation, 1 mole of this plus 1 mole of this should be giving me 1 mole of this and 2 moles of this. So if we were to start out with just a perfect example of what we would have if we, like a standard example, if I said 1 mole times 164 grams per mole, I'd be looking at 164 grams of calcium nitrate. 1 mole times 106 grams per mole is 106 grams of sodium carbonate. 1 mole times 100 grams per mole is 100 grams of calcium carbonate. 2 moles times 85 grams per mole is going to give me 170 grams of sodium nitrate. And remember, this is the point where we can do our check and we can catch ourselves, and if we've done something wrong in writing our formulas, calculating something, this is where we're going to find out what we did wrong. According to the law of conservation of mass, whatever's on this side should equal what's on this side. So I've got 164 plus 106. That's going to give me 270 grams on this side. And then I've got 100 plus 170 here, 270 grams on this side. Okay, so since my masses right here equal, I'm pretty confident at this point that I've got this equation set up correctly. Now, if these masses are not equal at this point, then I'm going to go back and I'm going to look and I'm going to say something is just not right. Now, we didn't start with 270 grams of this, did we? Well, excuse me, we did not start out with 164 grams of this. I'm going to go ahead and erase some stuff just so I can not get everybody too confused. Our equation said that we started out with 72 grams of this and we started out with 72 grams of that. So these are written in ratios of moles. Okay, chemical equations are written in ratios of moles. So if I want to know the ratio of what I'm given, I can take what I actually have divided by my standard. Okay, if I know that I want to make a cake and it takes 3 eggs but I only have 1 egg, then I can only make a third of that cake. So to find what that ratio is, this is just saying I've got 1 egg. My recipe for the cake calls for 3 eggs. So I'm going to take 1 divided by 3, and that means my ratio is a third. I've got to multiply everything in here by a third in order to make 1/3 of the cake. Okay? Now, that was just a fake number, so let's see what we actually have here. We're given 72 grams of this calcium nitrate. In our perfect little standard world, we would have 164 grams. So the ratio of what we actually have here, about a 0.43. We also know we're starting out with 72 grams of this. So let's see what our ratio is here. We've got 72 grams, but in our perfect world we have 106 grams. So 72 divided by 106, we already know that we're going to get a bigger ratio than the other one. Okay, so 72 divided by 106 is a 0.68 ratio. I didn't actually have to do this calculation because I already found my limiting reactant. Okay? Since this is my smallest ratio of material that I have, all this is extra. This is my limiting reactant right here. You find your limiting reactant by the smallest ratio. Going back to our cake example, let's say that we are making a cake, it takes 3 eggs to make a whole cake. We have 5 cups of flour. Well, let's say it takes 3 cups of flour. We've got excess flour because we can only make a fraction of a cake. And so that's what we've got going on here. We've got excess of this sodium carbonate here, and it's not going to be used in your reaction because this is going to be your limiting reactant. This is what's going to limit your whole thing. So now we're going to work with this ratio right here. Now if I want to know how much of this and this I'm going to end up with, I can just take this ratio and multiply it by our number of grams. So 0.68, I want to work with my lower ratio here. 0.43 times 100 is about 43 grams. 0.43 times 170 is in the neighborhood of 73 grams. So what this means is that I should be, according to my limiting reactant, the one that I have the least ratio, I should be, if everything goes perfect, getting 43 grams of this calcium carbonate. And I should be, if everything's perfect, getting 73 grams of this sodium nitrate. Now, nothing's ever perfect, no matter who you are. The problem originally stated that we got 39 grams of our calcium product. So we want to know, what is the percent yield? Well, remember, percent is just basically your part over your whole. This is our theoretical value. This is what we would get if everything went the right way. But not everything did. We had 39 grams out of the 43 grams. And let's see, I believe that's going to be about a 52%. Divided by 43. No, that's a 91%. So we got 91% of this. There we go. We got about 91% of this right here. My 53% is this one. If I want to know what the problem did not ask for my percent yield here, but if I wanted to know, I would just say 39, and in this case divided by 73. And that's where that 53% that I saw earlier comes from. Alright, so this was a 20-point problem because it checked many different areas. Number one, I could see whether you could do a double replacement reaction. Number two, I could see whether you could translate from a word into a formula. Number three, I could see whether or not you could balance an equation. Number four, I can see whether you know how to get the formula mass. I can see next whether or not you can get your mole ratios. Okay, so 1 mole of this gives us 1 mole of this and 2 moles of this. if we're doing it that way. Then I can see not only that you can do stoichiometry, that you can tell me how much you're supposed to get, but that you can identify what your limiting reactant's going to be. So there were, oh, and then also there was the percent yield part over here. So there were several different components to this problem. That's why it was worth 20 points.